we're going to calculate the equation of a circle when we're not given direct information. We're giving something such as the endpoints of the diameter or of the radius or some other information that could lead us to find the equation of the circle. So we'll start out with an example. Write the equation of a circle whose diameter has endpoints at 2, 8, and 4, -2. So I went ahead and plotted these on a graph just to get a good visual of what this looked like. So we're going to have a circle that goes through here, something around these edges here, but we know that this is going to be our diameter, this line between +2, +8, and +4, -2. Always remember when you're finding the equation of a circle, the radius and the center is what's going to bring home the bacon for you. If you can find those two things, you're in good shape. So let's start out and find the center. If you're given two endpoints of a diameter, the center is always going to be in the very center of that diameter line. So it's going to be the midpoint of that line. So to find the center of this circle, let's find the midpoint of the diameter. The way that we found the midpoint was by taking the x-coordinates and finding the average of those, and the y-coordinates and finding the average of those. So if we go through that here, we have a +2 and a +4. So we're going to take the 2 and the 4, add them together, and divide by 2. So 2 + 4 is 6, divided by 2 is 3. So the x-coordinate of our midpoint is going to be 3. Same thing with the y's. Let's take our 8 and our -2, and let's add those two together. So 8 plus a -2 is going to be +6, divided by 2, and going to be 3. So our midpoint is going to be 3, 3. And that midpoint of 3, 3 is also going to be the center of our circle, since we decided that it's at the center of this diameter. So I'm going to go ahead and plot that on our graph here. So our center of our circle is right there. Now we need to continue by finding the radius. The radius is going to be the distance from the center to any endpoint, including endpoints of the diameter. So now that we have a center and we have a couple endpoints, we can choose one and find the length of that segment using the distance formula, and then we will have the length of our radius. So let's go ahead and start out knowing that the equation for the distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. What we simply mean by that is find the difference between the x values, square it, find the difference between the y values, square it, and add them together and take the square root. So if we pop in some values, we have 3 from our midpoint right here, and a +2 since we decided to choose the point 28 up here. I'm going to go ahead and throw some extra color on this. The reason I picked this one is just because it had both positive numbers. I happen to like positive numbers because they're easier to work with. So we had this 3 here and a 2 here, subtracted them, the difference is going to be 1. We have this 3 here taken from our midpoint, and we have this +8 taken from the other coordinate up here. So the color isn't going to show quite as well, but we have the y-coordinate here of 8. Subtract these, and we're going to get 1 squared plus -5 squared. Again, if we subtract in the wrong order, it's not a big deal since we're squaring away the sign when we're using the distance formula. So we can be a little bit sloppy with the distance formula. And what this is going to equal is 1 plus 25, or the square root of 26. So our radius is the square root of 26. A little messy, but let's write our equation of the circle now. We're going to set it up as x minus the x value of our center squared, plus y minus the y value of our center, all of that squared, equal to the radius squared. We said x value of the center is positive 3. Y value of the center is positive 3. So we have x minus 3 squared plus y minus 3 squared. And that's going to be equal to our radius, square root of 26 squared. Take the square root symbol and we square that whole quantity, and we're going to end up with just 26. So this is the equation of our circle right here. Move on to one more example. Write the equation of the circle whose center is 3, 5, so in this case we're given the center, and is tangent to the line x equals 6. So I went ahead and drew in this line. X equals 6 is a vertical line, so I drew in that tangent line. And when something is a tangent line, that means that the circle touches it at exactly one point. And to show you how this would work, I'm going to go ahead and trace in a circle, starting at our center here. Right now it's touching at 0 points, 0 points. If I jump over here, it'd be touching at 2 points. You can see the only place that it touches at exactly 1 point is right there, where the circle just bumps up against that line. So our circle is going to look something like this. And we're given our center right in the start of the equation, or the problem. So it was 3, 5. Sorry about that. 3, 5. But now our radius, to figure out what that's going to be, you need to find the shortest path to our tangent line. In this case, it's just going to be going straight across. So in order to figure out that distance, we can just count. Our units down here are 1, so we can just count the number of boxes. 1, 2, 3. And I drew in that radius of length 3 right there. Just to reiterate, the tangent line is where it touches exactly once, and so the center to the point where the circle is going to intersect is going to be directly across from that line. Now if that line was a horizontal line, we would go down to that line. If it was a slanted line, it would be a little bit more of a complicated process to figure that out, but there are equations that could help you do that. So now to write the equation, we have the center, we have the radius. Just put it into our standard formula here. X minus a positive 3. It's going to give us positive 3 there. Y minus, I'm going to say positive 5. So that's going to give us y minus 5, all that squared. And on the other side, our radius is 3. If we square it, we're going to get ourselves 9. So that's the equation.